Hey everyone, think back to yesterday. We talked about solving 3 by 3 systems of equations instead of 2 by 2. Alright, and then the first two ways we talked about how to solve them is substitution and elimination, which we have already used before, right? So it's the same idea, just a little bit more work since it's a 3 by 3. And today we're going to go over our third way to solve a 3 by 3 system, which it's not graphing like 2 by 2. Instead, we're going to use matrices to solve 3 by 3 systems, all right? And we're mainly going to be doing that by putting whatever matrix we come up with into Desmos Calculator or Inspire and doing something with it in there to figure out what our solution is, okay? So if you'll look at these 2E notes, they should be attached on your Schoology page for you to complete. So the very first thing it wants us to do is give an example of a 3 by 4 matrix. So a 3 by 4 matrix, even though we have a 3 by 3 system, we're going to come up with a 3 by 4 matrix, which I'll show you why in a little bit. But let's look at a little review of how we even make a 3 by 4 matrix. All right, so once 3 by 4 matrix. Okay, so let's think about what those numbers mean, right? What does the 3 mean? What does the 4 mean? So this 3 is how many rows we're going to have in that matrix. And the 4 is how many columns we're going to have. So how many rows and how many columns are we going to have? Right, so we're going to have 3 rows and 4 columns, okay? So that would mean here is our matrix bars. We're going to have 1, 2, 3, 4 row or 4 columns, and then 1, 2, 3 rows, okay? So all those blanks are where you would put numbers. So go ahead and come up with, use whatever numbers you want, okay? Come up with a example for a 3 by 4 matrix. All right, awesome. So now we're going to be using a 3 by 4 matrix, like the one we created above, an example of that, to solve this system of equations below, okay? So here's our system of equations, right? And we know it's 3 by 3 because why? Because we have 3 equations and at most we have 3 variables. Now you'll see in this second equation right here, it's missing x, all right? But that just means that we have a 0 coefficient for x, which is why it disappeared. We still have 3 variables at most in these equations, okay? So we're going to use a 3 by 4 matrix to come up with this equation, all right? So if you look back on my notes over here, 3 by 4, right, we said we have 3 rows and 3 columns, okay? So let's think about what kind of numbers would we put in this matrix if it's going to resemble this system of equations right here. Okay, so let's look at equation 1. What coefficient is in front of every variable there? It's a 1, right? So on the very first row, we're going to have a 1 for x, a 1 for y, and a 1 for z, okay? Now, what's the last slot going to be on that row? It's going to be whatever our equation equals. So it equals 6, okay? All right, now look at the second equation. We're missing x in that one. So I talked about why are we missing x? That means x has a 0 coefficient. So we're going to have 0 for x. And then for the coefficient on y, we have 2. And then z is 5. Okay, and then whatever it equals is that last slot, so it equals -4. All right, and then our last equation, we have coefficient of 2 for x, 5 for y, and -1 for z. And then whatever it equals is the last one, so 27. Okay, so you'll notice that each row is its own separate thing in relation to that system of equations, right? So this row right here is our x, okay? This one right here is our y. This one right here is z. And then this one right here was whatever it equaled, okay? So that is how we come up with our 3x4 matrix looking at a system of equations, right? So now what we're going to do, so we came up with that matrix, right? So these are kind of the steps that we're going to follow to solve for this matrix to find our solution. So like I said, you could either put this in Inspire calculator or you can use Desmos. It has it on there too, okay? So what we're going to do is we're going to enter that matrix, the 3x4 matrix, into Desmos. So I'm going to open Desmos scientific calculator. Okay, here we go. All right, and once you're here, it should look like this. It should look like your normal calculator, right? You're going to click on Math Tools, and you'll see a bunch of different calculators. We're going to do the matrix calculator, so click on that. All right, so first thing we want to do is enter that matrix into our calculator so it knows what matrix we're talking about exactly. So we're going to say new matrix, okay? Then we're going to have to fix how many rows and how many columns we have. So we had a 3x4 matrix, which meant 3 rows and 4 columns. All right, that matches how many spaces we had. So now we're just going to enter the matrix that we came up with on our paper. So let's see, we had 1, oops, sorry, didn't mean to do that. Let's edit that. So 1, 6, and going down we have 0, 2, 5, -4. Then we have 2, 5, -1, 27. Okay, so that is matrix, and it just automatically put it as matrix A, but it could be any letter that you want it to. The letters come really in handy when you're working with different matrix. So that is how we enter that into Desmos. So let's go back to our notes and see what the next step was. So we entered that. Now we're going to find the button or the command that is reduced row echelon form, okay? And that probably seems like a lot of words you don't really know, okay? You don't necessarily need to know what like echelon means or anything, but we're just going to refer to it as RREF, okay? So RREF on the calculator is what it should look like. And we're going to apply that to our matrix that we entered, okay? So let's go back to our calculator. All right, so if you'll see, it's right here, the bottom left, RREF. We're going to click on that. Then it gives us some parentheses next to it. So what that means is it's telling us to put in whatever matrix that we want to find reduced row echelon form of. So the matrix we entered, that equaled matrix A, so we're going to click A. And then it automatically gave us our answer over here to the right, okay? So look back at your notes. It's wanting you to write down whatever answer it gave you. So go ahead and write that down. All right, and then look at step 3. It says, as long as the first 3 rows and 3 columns in that matrix give you the identity matrix, your last column is your solution, okay? And here's a picture of what an identity matrix looks like. All right, so this is pretty much what it looks like for 3x3, which is what we were looking at, the first 3 rows and 3 columns. So we have 1s going in a diagonal and then everything else is 0. So let's look back. All right, if you look at the first 3 rows and 3 columns, this section right here, does this look like an identity matrix, like the example I gave on the notes? Yes, right, we have a diagonal of 1s, everything else is 0 right there. So that means that if this part looks like that, our last column right here, that is our solution. So what is our solution? Go ahead and write your answer down on your notes. Our solution is going to be 5 for x, 3 for y, and -2 for z. So that is how we find our solution using matrices in Desmos or Inspire. Pretty easy, right? Okay, so after you finish that, go ahead and work out this next problem, okay, using a matrix in Desmos or Inspire to find the solution. All right, make sure you complete your notes and email a picture to Miss Riddell, and you'll have an exit ticket to complete after this. All right, and I will see you guys next time.